Alright, this is continuation of day 27 for Sparks Pre-Calculus. And we're going to start with supposing that a polynomial function has given roots of x equals -1 and x equals 2i. So when we see just two roots, we might think quadratic. However, if you recall, imaginary roots come in pairs. They're conjugate. Alright, so if x equals 2i is a root, then x equals -2i is also a root. So this function is at least a cubic. And if these are, well, it doesn't say they're all the roots, obviously, because we found another. So this is at least a cubic. And I think they're going to make us, or have us assume that there are no more roots than the complex conjugates right there. And the reason why we know there has to be at least 3 is because we're given 2, and then we know there's a complex conjugate for the third. Now we're going to find an equation. So we know since x equals -1 is one of our roots, then x plus 1 is a factor. The same thing with these complex imaginary roots. If x equals 2i is a root, then x minus 2i is a factor, and x plus 2i is a factor. Then we're going to multiply this out. I'm going to start with this one. That's a difference of squares. X squared minus 2i squared. Our little back cave work over here. 2i squared equals 2i times 2i, which is 4i squared, and I squared equals -1, so 4i squared equals 4 times -1, which is -4. So I'll plug that in here, and we still have this x plus 1 hanging out. So x squared minus -4, which is x, well, I missed the square, x squared plus 4. And then we're going to multiply out the next binomials. So we get x cubed. There's an x squared. Here's 4 x's. And then plus 4. And this is h of x. We don't know anything about the leading coefficient, so we're just going to leave it as 1. We get to do this again. Alright, see what you can come up with for what type of function this is, and give a reason for your answer. So pause this now. So I say this is a minimum of a quartic, degree 4 polynomial, because x equals 1 is a double root, and x equals 3 plus 1 is an imaginary root which has a complex conjugate of 3 minus I. And now we get to write an equation for g of x. So g of x is going to be equal to x minus 1 squared for the double root at x equals 1. And then we're going to have x minus 3 plus I. And then we have x minus 3 minus I. This looks like so much fun to multiply out. Alright, let's start with this mess. This is x minus 1 squared. That one will be easy. This is x minus 3 minus I, and this is x minus 3 plus I. I'm feeling there's going to be some stuff that drops out of there. Okay, so we're going to x times x squared, times -3x, and then we do this one here, so we have plus xi. We do the same thing with -3. There's -3x. Then there's positive 9, and then there's -3i. And we do the same thing with I. So we have -xi. We have positive 3i, and then we've got -i squared. And we still have this x minus 1 squared out front. So some of this is going to drop out. Let's see, the positive xi, the negative xi. negative 3i, positive 3i. And we remember that I squared equals negative 1, which we're going to put in right here. So we still have x minus 1 squared. And we've got x squared minus 6x plus 9. That looks nice, except for now we got to tack on this plus 1. Alright, so we have x, I'm going to multiply this one out now. X squared minus 2x plus 1. And then we've got x squared minus 6x plus 10. And what do you know? All this is nice and neat, and we have no i's. There are no i's left. How wild is that? And of course, we're not done. So now we're going to multiply this times this. Gives me a 4th degree. And then we do this times this, and that gives me negative 6x cubed. And then I get plus 10x squared. And then I get this one, which is negative 2x cubed. And then I get positive 12x. And then I get negative, that was a squared, 20x. And then I've got 1x squared minus 6x's plus 10. X to the 4th minus 8x cubed, 10, 22, 23, x squared minus 26x plus 10. And this is g of x. There you have it, folks. That is the end of day 27 lecture. We'll see you next time.